Hello, everyone. Good afternoon. So I'm the last one of the day, so hopefully you're not so tired. So my name is Tobias. I'm research software engineer at National Oceanography Center, and I'll talk a little bit about PAIDIVER. So just to give you about what's PAIDIVER, PAIDIVER is an open source and Python package designed to create pipeline for preprocessing image data for biodiversity analysis. So the idea is try to standardize the preprocessing steps while you can maintain detailed documentation and version control and traceability of your data set and your preprocessing steps. So in the end, the idea of PAIDIVERPY is to ensure that each image and preprocessing steps is traceable for reproducibility. During the sessions, I will give you like a brief overview of PAIDIVERPY developments, and I will try to give this overview highlight. I'll try to highlight the key steps of creating an open sourcing package. So if you look on the internet, a lot of us, we are research software engineers, so we develop open source package all the time. So each person has some kind of way to do that. So this is the way that I follow, or the steps that I follow, but each people do slightly different, but in the end, the idea is like that. So I try to follow my presentation through this step. So starting from the scientific idea. So my problem is the scientists want to do biodiversity monitoring in imagery. So they want to collect image data. So the scientists that I'm working with, they are biologists, marine biologists. So they want to collect image data and having some biodiversity metrics. But you know that between that, you need to do a lot of image preprocessing to prepare the data to AI models. And image preprocessing are really important steps because it's essential for ensuring trustworthiness of the biodiversity metrics. So properly selecting and documenting preprocessing steps is crucial for reproducible biodiversity research. So I'll just show two examples papers. This first one from 2014, they apply some preprocessing steps in images collected by autonomous underwater vehicles to study wide resolution assessments of seafloor habitats. So they apply some color correction, remove low quality image, color rectification, remove overlap image. So they want to prepare image to do some type of analysis. This other paper from 2022, they apply some image preprocessing method to prepare large-scale plankton imagery for trait extraction and analysis. So they got raw image, filter image, clean the image, detect some organism on the image, and then store the outputs in network or local storage. As you can see, these two papers, they do kind of similar stuff, but in a different ways. And the problem is that image preprocessing is a challenge because we have different types of instruments, cameras, we have different types of sampling methods, we have different types of site conditions, we have a multitude of image and preprocessing approaches. And each preprocessing approach can have numerous hyperparameters adjust. We need to handle metadata. We have like different tools and manual processing. So this is just some of your examples of tools. And those preprocessing steps not intuitive for all types of users. We have some users that know how to code, some other users that don't know how to code, they prefer to use graphical user interface. So in the end, every project starts from scratch and there's something slightly different. So that's why we try to bring PAIDIVERPY to make the pipeline easier and in the end ensure that each image and preprocess steps possible for reproducibility. So now that you have the problem and the idea of solution, we start to think about design. So the idea of PAIDIVERPY is try to helping people building pipeline for image preprocessing. So when I start to think about that, I remember about scikit-learn. I think everyone knows about scikit-learn. It's a Python package for data science. So they have a really good idea about creating pipelines, and I think, oh, PAIDIVERPY should follow this idea. I think everyone uses scikit-learn to make the life of people easier if I use that. And we have XArray format that's really good for dealing with n-dimensional array. So if you treat the image data set as an XArray data set, it will make my life easier. You can apply desk easily. You can apply parallelization. You can use, because it's built on top of NumPy, you can use vectorization. So the performance will be much better. So, and another thing that's about design is that I don't want to reinvent the wheel, so I don't want to create new algorithms to process image data. We already have a lot of tools already available in Python, like OpenCV, Scikit-Image, Pillow, and several others. So instead of creating new algorithms, I just integrate those existing algorithms in PAIDIVERPY, and I separated PAIDIVERPY in several types of layers. Each layer is work kinds of Python class. So I have a layer that dealing with open image, one for convert, one for dealing with position, with sample, color. If you want to add your own algorithm to the code, you have a layer for that. And we have a configuration layer that have information about input and output path. We have a metadata layer that has information about the data set and each individual image. And you have a pipeline layer that integrates everything together. And then you get the raw image and you have in the end your processed image. And to integrate everything together, to be able to, for the pipeline layer, to integrate everything together, we designed the package to work driven by a configuration file. So we have the package to work with a configuration file where you set inputs, output path, metadata path, and all the preprocessing steps and hyperparameters. And when you have all those informations, the package would create the pipeline automatically, and the package would not be able to deal with parallel batch and pixel processing. So now I have the design. Now is the difficult part, starts execute implementation. So about the configuration file, so we decided to work with a YAML format. So YAML format, it's easy to read. So people that don't know how to code it, they can take a look on that and understand a little bit how it works. And to organize each field on the configuration file, I work with Pydantic models. One problem that people that work with Python, they complain a lot is about typing. And I think Pydantic solved these typing problems in a really good way. And another good thing about Pydantic is that it's really easy to export Pydantic models to JSON schemas. So JSON schemas, you can validate JSON schemas with a lot of tools available, tools in JavaScript, Python. So this saves a lot of work in my job, because when you create a configuration file, I can validate the configuration file through the JSON schema before starting the pipeline. So this makes the package much more robust, because it avoids you to include like wrong hyperparameters in the code, for example. About metadata, the package supports simple CSV files. And so if you have like tabular files, and it also supports IFGO metadata. IFGO, for people that are not familiar, is like a FAIR metadata for image that follow the FAIR principles. We are planning to add AI-friendly metadata like croissant in the future. And we're also implementing the package some tools to validate and generate IFGO estimated metadata. So if you have a metadata in CSV, you can export to IFGO. About imaging formats and storage, so the package can handle local and remote images. When I say remote image in object store, and the format, it can handle the most common formats, but for people that work with images, like seabed image or even medical image, normally we work with raw formats or proprietary formats, and tools like OpenCV, Pio, Image.io, they cannot handle this type of data easily. So there is a Python library called RawPy that can handle most of those parts of data. However, for some types of data, we need to build like some custom loaders. So we implement in the package some ways to load raw images, like you just need to parse to give information related to the width and height of the image, pitch, depth, engine, and swap bytes. And even if you don't want to use PAIDIVERPY to create pipelines, you can use it to load your raw image, for example. So the idea is that you can use PAIDIVERPY as a custom loader as well. So about performance and image rendering, so as I told you before, it's work on top of X-array, so it can handle sequential processing, parallel processing using threads, or if you give information about clients on the configuration file, you can run it in a local or Slurm cluster. And just an example of a really, really simple benchmark that we made some calculations. I still need to work more on the benchmark calculation. We increased it takes 50%, 55% of the time if you use for workers and for threads compared to sequential process. So just a really simple benchmark calculation. It's something that I need to work more to create better computation and put it in documentation. And as I said before, we don't want to reinvent the wheel, so we don't want users to create new algorithms or to just use our own algorithms. So if they want, they can upload their own algorithm to the package. So they just need to set on the configuration file some information about the algorithm, like where is the file, the dependencies that they need to use, and maybe you need to adapt your algorithm to the input and the output data. And we put in the tutorial how you can do that, so how you can implement your own algorithm in the code. And how to run the code. So you can run the code in two ways. The first one is a Python package. So I have an example notebook here. Hopefully it will open. So with just 3 lines of code, you can run it on Python. It's bigger, maybe. So like the first line to import the package, the second line to instantiate the pipeline class, and the third line to run. So for example, if you have this configuration file here that runs these steps with these hyperparameters, and it's using parameterization, with 8 threads, we can run 3 lines of code. So we also have in the package some sample data. So we can use the sample data to test some steps, to test the package to see if it's working fine. And so I import the package, instantiate the pipeline class. We also integrated in the package some, so this is a Jupyter notebook, by the way. So I also integrate some HTML stuff. So you can, just to make the life easier for the people that to take a look on the steps, so to see the hyperparameters of each steps. You can see the configuration, you can see the metadata, and when you run the code, you can see the output of each step, and you can even see like a thumbnail of the image after each step. So the raw image after color correction, date time, return overlaps, for example, color correction, sharpen, and then if you are happy, you can export the image to PNG, for example, or some other format. And we can also run the packs as a command line interface and as a Docker container if you don't want to install things. So, and one thing that we just implemented like 1 month ago is creating a graphical user interface. So the idea of the graphical user interface is try to make something that would be easier for the researcher that don't know how to code. So let's return to the presentation. So I built this like using panel and all of these, and I convert the Python models into forms, and I also integrated the HTML components that were in the Jupyter notebook in the code. So the graphical user interface was built to work locally, but I just deployed a web version for this presentation. So here you can create like a form, creating create some steps. So I create a general step here. I can add a new step, like apply some contracts in my image data. And then I can add the step, and you can see here that the configuration file is updated. All the commands, all the Python commands to generate the configuration file is here. So you can run the pipeline. You can see the outputs. So if you are happy with the image, you can save the image. Or if you want to run, just copy and paste to run it outside the graphical user interface, you can do that as well. So we try to build something to help scientists to run this package for people that don't know, that do not have experience coding. So now about code quality. So we implement tests using PyTest and tests. We try to achieve above 85% of test coverage. It's really difficult. We integrate code in the CI/CD to calculate the code coverage. For people that are not familiar, code is really good to find missing lines and to put a badge in your package to other people to see how reliable is your code. About linting, I'm using Roof. I don't know if people are familiar with Roof, but Roof is amazing because it integrates together PySort, PyLint, and it's faster. So I really recommend you to start using Roof if you've never used it before. About documentation, so I built the documentation using Sphinx and deploy it on Write the Doc. About API reference, I'm using Alt API that converts all the doc strings to API reference. And I'm implementing the CI/CD ways to run the examples notebook, checking broken links, and deploy to RT to write the docs. So just show the documentation here. And documentation for research software engineers is a really important part because you have to spend a long time with that if you want to make your codes usable for other people. So I spent a long time here. And I put a lot of several user guides on how to create custom algorithms, how to deal with performance. And I also create a gallery of several good notebooks that people can take a look to test the package later. So about release, I'm using for the pump my version for package versioning. And on the CI/CD, I'm deploying PyPy and test PyPy. For Conda Forge in BioConda, it's a little bit tricky because we need to generate a Conda meta file. So I'm generating this file on the CI/CD as well. And on the CI/CD, I'm generating the changelog files for the new version. So maintenance and user feedback. So like the workflow using GitHub issues and dev and main branch. Just take a look at the side. So workflow using GitHub issues and dev and main branch. So this package is not being used a lot for people outside of the project, so the group. So that's why all the GitHub issues that we have right now were created by the people that work in the project. But we want to try to gain feedbacks for this package. So we try to present it as much as we can in conference and submitting papers. So this is the third place that we present this package. We are planning to submit a paper to JOS by the end of this month, hopefully. And we still have 2 other presentations on the next few months. We also plan to have some workshop with end users. So we had a workshop with some users in March this year. So we create ready-to-use environments, interactive tutorials, and created sample data sets. And we also plan to have 2 or 3 workshops with end users by the end of the year and beginning of next year. So now that we have user feedback, we have everything, and that's the problem of our life. We need to think about the new problems and then try to find solution and start everything again. So it's an endless job. We all know about that. So next steps. So I want to publicize the package. So that's why I'm here today. I want to have more people using it. I want to have more people improving it. It's an open source. So there's a lot of things that I need to improve on it. We want to do some workshops with end users. So we need scientists, biologists to test it, and also test the graphical user interface because it's a new idea that was not in the initial plan before. We also plan to add new preprocessing steps, image preprocessing steps. We also plan to add some ways to export metadata to AI-friendly formats like Russell. And we also plan to export image to other formats, like not just PNG, JPEG, but also GeoTIFF. So like for seabed image, so in GeoTIFF you can add in any type of GIS application. And as we are working with X-array dataset, you can export the idea is that you could export the image to ZAR formats and to be able to work with. There is a type of format that's it's used a lot in medical image called next generation file format. So that is that you could integrate these file formats PAIDIVERPY as well. So PAIDIVERPY is ready to use. However, it's still active development. So it's a lot of updates and changes. So the API features, it's evolving as we are continuing improving it. So these are the links for the GitHub, PyPy documentations, and Odoo, and the workshop website that we prepare for end users in the beginning of the year. And this project is supported by NERC in the AI and B Foundry opportunity. So that's it. Thank you very much for your time.
All right, so how extensible is the package? For example, how do you write an algorithm count colonies on a petri dish from images? How easy would it be to adapt his code to a pipeline in your library?
So the package, so if you have a custom algorithm, the package expects that your custom algorithm would receive as input metadata and the image in NumPy, and would expect you to export your data in the metadata and the transformed image in NumPy format. So if you can adapt your code to do that, so in this case you have like counting columns of petri dish. I don't know what's it, but if you just if you just need to update a metadata, like add a column to a metadata, it's I think it's quite easy to adapt your codes to the pipeline.
Great. How easy do you find modifying the configuration files? Was there any significant increase in the uptake after creating the graphical user interface?
Yes, that's why we still need to test the graphical user interface, because this package is only been tested by our people from the project, so they are not using the graphical user interface yet. So yeah, we need to how can I say? We need to put it in testing for end user to check if if it's useful, if I still need to implement new features on that, or if I just need to throw it away and stop doing anything on that. So yeah, I don't. There's no answer for that question.
Have you explored EXIF data, PNG format, etc.? Are there any weaknesses that will not make it suitable for these formats?
So the EXIF data it's a problem because all the researchers, they want to have access to EXIF data, and because of that, my initial idea was to lazy load image. So I don't want to load the image to the memory. However, to load EXIF data in remote images, I need to load the image into memory to get the EXIF part. So yeah, I load the image, get the EXIF, and add the EXIF data to the metadata. So if you have a metadata, the metadata will be updated with the EXIF information. So yeah, so the weakness is that it's avoid me lazy load image, so it's decreased performance. And depending on the output format, it's difficult to add the EXIF data again to the image. So because I think JPEG chief may accept EXIF, but PNG and other format do not accept EXIF, so it's a little bit tricky on how to update that. So that's another weakness.
Okay, and in terms of other tools in this field, how does package incorporate with those?
Tools to build pipeline, I'm not pretty sure, but yeah, there's a lot of tools to build, to create algorithms to process image. So PAIDIVERPY just call those algorithms OpenCV, scikit-image, and to process image, but I'm not pretty sure if there's other tools to create pipelines for process images.
Question just in. Could you talk a little bit about scikit-learn pipelines? What is that for the beginner?
Yeah, so just scikit-learn is a package for data science. So if you have like a data set, you can use scikit-learn data set that you want to apply some machine learning model. Like maybe I don't know if Splash used, for example, Splash the presentation that was in the beginning of this presentation. I don't know if they use scikit-learn, but if they use scikit-learn, they have some type of pipeline that do some transformation in the data and prepare the data, like remove normal number values and then apply the random forest model. So this is the pipeline, like adding steps in the middle to have some output in the end. So that's how scikit-learn works. So, but for data science, not for this field. I only mentioned scikit-learn because of the idea of pipelines.